All right, 6.7 notes, exponential and log equations. So today we're going to solve exponential and log equations. So if we have an exponential equation, it's when you're solving for the exponent. So in this example, if we have 2 to the x power equals 64, we're trying to figure out what x value as the exponent will make this equation true. There's two ways to solve this equation. The first way is to solve by using equal bases. So step one is to make the bases equal, and you always want to go smaller. Then you would set the exponents equal, and then just solve for x. Sometimes, though, it's not possible to make the bases equal, so then you have to solve by using logs. So to do this, you would get the term with the exponent alone, do the hook method like we learned the other day, and then solve for x. So number one says to solve by making the bases equal. So notice the bases are equal. The 2 and the 2 are equal. So I can make the exponents equal to each other. Part B. Notice the bases are equal to each other, so I can set the exponents equal to each other. Now I'm going to solve for x. So subtract the x over. You get x minus 3 equals 6. Add the 3 over. You get x equals 9. Notice in this case, the bases are not equal. So to make them equal, you always go smaller. So I'm going to turn the 4 into a smaller base of 2. So this side is not going to change. But I'm going to rewrite the 4 as 2 squared because that is equivalent to 4. But notice we already have an exponent there that needs to drop down. So the 3x is going to drop down. Since we now have our bases equal, you can say that x minus 8 equals 2 times 3x, which is 6x. Subtract x from both sides, I get negative 8 equals 5x. To get x by itself, divide by 5, so it's negative 8 over 5. Sometimes people are tempted to turn the 2 into a 4. You don't ever go bigger. If you square this, you've just made the left side bigger without making the right side bigger. So the goal here is to always go smaller. So if we're trying to go smaller, notice the 125 is a big number that I can rewrite with a base of 5. So the left side drops down, and then the right side becomes 5 cubed, because 5 cubed is equivalent to 123. I didn't make this side bigger, I just rewrote it. Now that my bases are equal, I can set the exponents equal to each other. Add the 6 and divide by 3. So x equals 3. For E, we're trying to go smaller. Notice I can't do 4 to a power to get 8, so I have to go smaller with both of my bases. So the smaller number would be 2. So 8 can be written as 2 cubed, drop the exponent, equals 4 can be written as 2 squared, drop the exponent. When your bases are equal, you can set them equal to each other, and then we need to distribute. So 3 times x is 3x, 3 times 2 is 6, equals 2 times x is 2x, 2 times negative 3 is negative 6. Subtract the x from 2 x's from both sides, you get x plus 6 equals negative 6, and then minus the 6 over x is negative 12. For F, we have an 81 and a 1/3. To make them equivalent, we're going to make them both have a base of 3. So it's 3 to the 4th power, that's equivalent to 81, drop down the exponent, equals, to make this a 3, this needs an exponent of negative 1, because remember that flips the base, and then drop down the exponent. So we can just, the bases are equal, we can set the exponents equal to each other. We distribute, 4 times 3 is 12, 4 times negative x is negative 4x, equals negative 5x plus 6. I can add the 5x over and then subtract the 12 over, so x equals negative 6. Number 2 says to solve by taking the log of both sides. Notice it is not possible to make 5 have a base of 3. 3 to the 1 is 3, 3 squared is 9. It's got to be between 1 and 2 to make this equation true. So my making bases equal doesn't work. So instead, we're going to make this a log equation. So we have to write the word log if we're going to make a log equation. The base of the exponent is the base of the log. Then you hook over to the other side, equals hook back to the exponent. Now that you have the x by itself, we can type this into the calculator as log base 3 of 5 by typing it in as log of 5 divided by log of 3, and you get 1.46. For b, notice you can't have an x value that will make this true. It won't be a nice, pretty whole number. I can't rewrite this as 11 squared. So we have to do the log. Log base of 11, hook over 100, equals hook back to the exponent x. So you would type into your calculator log of 100 divided by log of 11, and you get 1.92. For C, notice my base is not alone. So I have to start by subtracting the 5 over, and then I have to divide by 7. Now the base is by itself. So I can do the conversion to a log, but this is log base E, which is natural log. Hook over to the 2, hook back, you get x minus 2. To get x by itself, I'm going to add the 2 over, and you can type in natural log of 2 plus 2, and you should get 2.69. Part D, I have to get the base by itself, so multiply both sides by 3, and then divide both sides by 2. My base is by itself, so I can write it as a log equation. So it's log base E, which is the natural log, of 15 equals 2x. Divide both sides by 2. Type that into your calculator. You're going to get 1.35. All right, logarithmic equations. This is when you have equations with logs in it. To solve, step 1 is to get the term with the log alone. Then condense if needed, do the hook method, and then solve for x. So in this case, we have the log in our equation. So we're going to do, there's no condensing, there's only one log written out, so there's no condensing needed. So we can go to the hook method. So it's 2 cubed equals hook back over x minus 4. 2 cubed is 8. Add the 4 over, x equals 12. For B, notice the log is not alone. I have to minus the 5 over, then divide both sides by 2, and now I can do my hook. The hidden base is E, so it's E to the negative 1/2 equals hook back over x. When you type in E to the negative 1/2 to your calculator, you get 0.61. Notice the log is not by itself. I have to add this 5 over to the other side and then divide both sides by 2. Now I have the log with the parentheses by itself. So now I can do the hook. So it's 7 to the 6th power equals 3x minus 2. Well, 7 to the 6th power is 117,649. Add the 2 and divide by 3. For D, notice we have two different logs. This means we have to condense them to a single log term. So these are going to both become log base 6 together. The plus means we're going to be multiplying the 3x and the x minus 4. Because remember, when you condense with a plus, it means to multiply. And then we can just drop down the equals 2. So now I can do the hook. We have 6 squared equals, hook back over, we have the 3x times x minus 4. 6 squared is 36 equals, we can distribute and get 3x squared minus 12x. We have a quadratic equation. You always want to equal to 0 when you're solving a quadratic equation, so I'm going to minus the 36 over to make it equal 0. Notice you can factor out a 3. We can divide everything by 3. That'll get me x squared minus 4x minus 12. Now I can t-chart. X squared would be x and x. This has to multiply to negative 12. You could try 4 and 3, but this time it has to be 6 and 2, where the 6 is negative. So you get a negative 6x plus 2x. Notice that gives you your middle term. So each of these factors equal to 0. You're going to get a positive 6 and a negative 2. But you can't take the log of a negative number, so this one needs to be crossed off because it would make you be taking the log of a negative number. Okay, we have multiple logs. These are going to get condensed to a single log term. And then the plus means I'm multiplying the x and the x minus 3. And then you can drop down the equals 1. Now that you have a single log term, you can do the hook. The hidden base is 10. So it's 10 to the 1 power equals x minus 3 times x. So 10 to the 1 power is 10 equals x squared minus 3x. Subtract the 10 over. T-chart, x and x, 5 and 2, where the 5 is negative. So notice negative 5x plus 2x does give you a negative 3x. So each of these to 0, I get a positive 5 and a negative 2. But once again, you can't take the log of a negative, so we have to cross off the negative 2. All right, then we have this one. We're going to condense to a single log base 3. The minus means the x is going to go on the bottom. So this is going to be log base 3 of x plus 2 over x, and then drop down the equals 2. Do the hook, so we have 3 squared, which is 9, equals x plus 2 over x. You can multiply both sides by x, so the x's will cancel on the right side. So that gives me 9x equals x plus 2, minus the x, and then to get x by itself, divide by 8, and 2 divided by 8 reduces to 1/4. I'm going to skip the rest. I'm sure you are super bummed, right? All right, I'll click until you see it all in case you are dying to know something. But I hope you understand.